These are notes 7.5. We're going to talk about determinants first, then how to use those determinants in Cramer's rule to solve a system of equations. Okay, so the determinant is there's a number that's associated with every square matrix. Okay, and we're going to use that later to find the inverse and then also to solve using Cramer's rule. So the determinant, we say det of matrix A. And what we do is we just want to remember this direction minus that direction. Okay, you want to remember that. So what you do is you take this one times this one, okay, multiply those together, and you take this one times this one and multiply those together. And then you want to subtract the two numbers. Okay, so we would have negative 3 times 8 is negative 24 minus, going the other way, minus 24. So negative 24 minus 24 is negative 48. So the determinant of this matrix is negative 48. Okay, pause it and do this one. Okay, we're coming back. So 5 times 8 is 40 minus 3 times 7, 42. So my determinant would be a negative 2. Okay, we can also kind of make equations out of this too. If I know the determinant and I need to know one of these numbers, so I know that 5 times x minus negative 3 will equal the determinant of 33. That just makes an equation for us. So that'd be 3, subtract the 3 over, I know 5x is equal to 30, therefore x, this number here would have to be a 6. Okay? So that's how you find the determinant of a 2 by 2. A 3 by 3 matrix. Okay, I'll teach you how to do this one. It's a little bit harder. So what we're going to do is we're going to take these first two columns and rewrite them. Okay, now there's going to be 3 of them that go this direction. I'm going to circle them here. Okay, so we're still thinking this direction minus that direction, right? Okay, so what we're going to have here is we have to multiply these together. So 2 times negative 4 times 2 would be negative 16. Negative 3 times negative 3 times 1 would be negative 9. 2 times negative 1 times 0 is 0. Okay, so that's all the ones going this direction. And I want to subtract the ones going that direction, right? So if I put these together, it'd be negative 25. Okay, minus, now I have to find all the ones going this direction. And I'll do that in the red pen just to give you the difference here. Okay, so all the ones go, the 3 that are going this direction here. So negative 1 times negative 4 times negative 2 would be negative 8. 0 times those numbers are 0. And 2, negative 1, and negative 3 will give you 6. Adding together gives you negative 2. So if I take negative 25 minus negative 2, I get negative 23. That is my determinant of this matrix. Okay, so go ahead and pause the video and try this one yourselves. Okay, now that you're back, and watch me do it. If you have questions, remember to rewrite them. This one's going this direction. Minus one's going the other direction. Okay? So this times this times this would be 3. And 20 times negative 2 would be negative 40. And 9 times 2 is 18. So it's all those. Minus one's going the other direction. Okay, so negative 15, 8, is that a negative 3? Yeah, negative 3 times 2 would be 18. Okay, now we gotta add these all together and subtract. So 3 minus 40 plus 18 gives me negative 19. And negative 15 plus 8 plus 18 gives me 11. And negative 19 minus 11 gives me negative 30 as my determinant. Okay? Now, I will also show you in another video how to do this on Desmos. So all you have to do is put this matrix into Desmos and hit determinant of matrix A. Okay, real simple. But I'm going to want you to show me the work to it as well. By the way, if you read the textbook, they do this a little bit differently. They do something with minor and major and cofactors and all the stuff like this. I think this is a much easier way to find the determinant. Okay, Cramer's rule. You can look in your textbook if you want to derive it. I'm not going to go through the process of deriving it. But if you have this system of equations, and if you use eliminations, you can solve this out. And eventually, you would come up with x is equal to these determinants, and y is equal to these determinants. So the general rule is that way you can find x is determinant of this matrix divided by d, and y is determinant of this matrix over that one. Okay, so I kind of have it written out here in our notes. Let's see how it works. Okay, so the standard d determinant, okay, the one that it's divided by is just going to be your coefficients. Okay, 5, 7, 6, 8. Okay, the d sub x, okay, that I'm going to use here is use these numbers and these numbers. And dy is the x's here, and then your constant back here. Okay? Now, so if I work out these determinants, okay, this one here would be 5 times 40 minus, we already did it one up top there. No, we didn't. 42, I get a negative 2. Yeah, we did. Right, this one here, anyway. Determinant here is negative 8 minus 7 would be negative 15. And this determinant here would be 5 minus negative 6, which would be 11. So to solve this, solve for x is going to be d sub x, which is negative 15, over d, which is negative 2, which gives us 7.5. And my y is going to be d sub y, which is 11, over the d, which is negative 2, which would be negative 5.5. Okay, so that's a real nice way of solving a system of equations. The way we've done it in the past, we've used remember in 7.1 we used substitution and elimination and graphing. Here's another method of how you can do it. Oh, and also in 7.3, 7.3 we also used getting matrices in reduced row echelon form. So learning different ways of how to solve these. Okay, so let's go to the next one. So we can also do it with 3 by 3 matrices. Okay, so you have your d here, right? Just your coefficients. Dx will be this last one here, and then your y's, and then your z's. Dy would be your x's, your constant, and then your z's. And dz, okay, we were solving for the z's, dz would be your x's, your y's, and then your constants. Okay? So we have to find the determinant of all these numbers. I'm okay if you also do this in Desmos to get it. So that would be negative 3, and 1, and 4. So that would be 2 minus 1, and negative 2, and 6. So we get negative 3 there. Okay. 2 times 3 is 6. 4. And 5, negative 10. 0. 4. 4. Negative 15. 8 minus 15 is negative 7. So this would be 7. Okay, I won't bore you here by finding these, but hopefully you find these here. Okay, I worked those out here. That's negative 22 and negative 21. Okay, so now to find the x is going to be dx over d. So dx was 7 over d was negative 3. So my x, my y would be dy, which was negative 22 over d, which is negative 3, which is 22/3, and dz over d would be 21/3. Okay, so yet another way of how to solve the systems of equations.